Hey guys, so today we're going to focus on phase change diagrams. All right, you know what a phase change is. You know a phase change is when a state of matter can change to another one. So solid changing to liquid. All right, and we know matter can change from one form of matter to another form of matter if thermal energy, which is just heat energy, is added or removed. Okay, so we are still on standard SP81B, which states that we can develop or use models to describe the movement of particles in solids, liquids, gases, and plasma states when thermal energy is added or removed. Because we are going to master standards, you are focusing on using a model. That is what a diagram is. So if you can actually draw and read a phase change diagram, that means you can use a model to describe the movement of particles in states of matter, which would mean that you have mastered this standard. Okay, so some vocabulary that we need to know. So we do need to know that the definition of thermal energy is that energy within a system is responsible for its temperature, which is just heat energy. For this specific video, you need to know what a constant is. Just like in math, it's the same thing in science. It's a number that is fixed and unchanging. So if it is constant, it is going to stay exactly the same. And then temperature. So the temperature of a substance is closely related to the average kinetic energy of its molecules. Kinetic energy is energy in motion. And we know that in all states of matter, the particles are always moving, so they all have kinetic energy, okay? So when we are watching this video, here are your look fors. You are going to look for what happens to temperature during a phase change. You are going to look for the names on the X and the Y axis because it's a table just like you have in math. And then you are going to look for, as heat is added, what is happening to the particles in the different states of matter. Is the kinetic energy in those particles increasing? So movement, kinetic energy, energy in motion. So is the kinetic energy increasing? Is the kinetic energy decreasing? Meaning, are the particles moving more, increasing, or are they moving less, decreasing? All right, guys, so what you are looking at is called a phase change diagram, and it's just a way to show what is happening when you have a phase change. And remember, phase changes occur when one state of matter changes to another. And just in case we needed a reminder, matter is anything that has mass and takes up space. So the first thing you want to notice about this diagram is that it is some type of table, okay? And in a table, just like in math, you have an x-axis and a y-axis. You have the same thing on the phase change diagram. So on the y-axis, you have temperature. And as you can tell, I actually put the degrees of temperature. So the temperature is degrees Celsius. And I added arrows going up because as we move up the y-axis, temperature is increasing on the y-axis as you go up. And then you have the x-axis, which runs horizontally, and the x-axis is heat added. And as we increase heat as we move to the right, which is why you have an arrow going this way. So as we move this way on the x-axis, heat is increasing, okay? So in a phase change diagram, you have to have a y-axis and an x-axis, and you do want to name both of those axes. Okay, so on this phase change diagram, if we start at the bottom of the table, as you can tell, you have a solid. So a solid is on the line that is increasing. I have the word solid, and then I drew the particle arrangement of a solid. We know solids vibrate, and they have this crystalline type of arrangement, meaning they're tightly packed together. So we have solid, and since we're moving up the table, what I am noticing is that a solid is increasing in temperature as heat is added. So a solid is increasing as we're moving up as heat is added. And then we get to this plateau. So we know temperature is still increasing if we move up, but we are at a plateau, okay? So that means there is no temperature change right here because the line is no longer moving up. Once again, there is no temperature change. The line is no longer moving up. It's going this way, so heat is being added, because we're still moving on the x-axis, but no temperature is increasing. So if this was 10 degrees, it would stay 10 degrees even though heat is being added. So what is happening when the temperature is not changing, but heat is still being added? A phase change is happening. So at this moment, while heat is still being added, but the temperature is staying the same, this solid is turning into a liquid. It is melting. Once again, a phase change occurs when the heat is still being added, but the temperature stays exactly the same. So this solid is now turning into a liquid. All right. I drew a particle arrangement of a liquid, or I tried, and we know what a liquid does is that the particles in a liquid, they glide or slide past each other, just like how you would do if you were rubbing your hands together. So we're here at a liquid. As you can tell, the line is moving up again, so temperature is increasing and heat is also being added. And then we get to another plateau. If we're at this plateau, I'm still moving on the x-axis, but I'm no longer going up on the y. So what that tells me is that heat is being added, but the temperature is staying the same. Once again, I have a plateau. I'm still moving along the x-axis, so heat is being added, but the temperature is going to stay the same. So I have a liquid, I got to this plateau. So what is happening when that temperature is staying exactly the same is that evaporation is occurring. So I am here, I am at a phase change, and evaporation is occurring. So that liquid is now turning into a gas. A phase change is occurring when heat is being added, temperature is staying the same, evaporation is occurring, so a liquid is now turning into a gas. And from here, once we get to a gas, my line is moving up again. So that means my temperature is increasing now and heat is still being added. I have a particle arrangement of gases because we know the particles in a gas move freely, they bounce around, and they're all over the place. They don't touch, all right? So if you see a trend, and you should by now, when you have a phase change, the temperature is staying the same. When you have a phase change, the temperature is staying the same. And you can tell because there is a plateau in our lines. All right? So I'm going to go over it again. A solid is rising in temperature and heat is being added until it gets to a plateau. At that plateau, a phase change is occurring. It's turning into a liquid. That phase change is considered melting. And then when it turns into a liquid, as you can tell, that line is still going up. So temperature is increasing, heat is being added, and then we reach another plateau. What is happening at that plateau is that there's a phase change occurring, which can only occur when temperature stays the same. That phase change is evaporation. Once we have reached full evaporation, that liquid is no longer a liquid. It has turned into a gas, all right? The way I just read this phase change diagram from the bottom to the top, I can also read it the opposite way because we know a gas can turn into a liquid. So when I am removing heat, this is what happens. So if I am a gas, I already have a high temperature and heat is being removed from that gas. We're going to go backwards. So now we are here at a plateau. When a phase change occurs, it occurs when there is no temperature change. A phase change occurs when there's no temperature change. Heat is being removed, so I'm at the phase change of condensation or condensing. So that gas is now condensing and turning into a liquid because heat has been removed. So now I'm here, I'm at a liquid, my line is going down, heat is being removed, temperature is decreasing. And then I get to another plateau. When I'm at that plateau, a phase change is occurring because the phase change happens when the temperature stays the same. There is no change in temperature when you have a phase change. So my liquid has hit a plateau. And the reason why it's hit a plateau because the liquid is freezing and turning into a solid. So takeaways from this lesson, remember phase change occur when temperature is constant. Phase changes occur when temperature is constant. Constant means stays the same, okay? The 4 phase changes that you need to know is that when a solid turns into a liquid, it is considered melting. When a liquid turns into a gas, it is considered evaporation. Let me say it again. When a solid, when there is heat added to a solid, it turns into a liquid, which is called melting. When heat is added to a liquid, it turns into a gas, which is called evaporation. On the flip side of that, when heat is removed from a gas, it condenses and turns into a liquid. When heat is removed from a liquid, it freezes and turns into a solid. So in class, make sure you're using all of these vocabulary words because they will help you answer correctly on questions, tests, quizzes, check understandings, and everything else. And that's it. All right, so just to review, we know there are 4 phase changes: evaporation, condensation, melting, and freezing. Thermal energy, which is just heat energy, can be added or removed to change states of matter. Each phase change is reversible, which means it's a physical change, and it does have a pair. So melting and freezing, they are pairs, and evaporation and condensation, they are pairs as well. During a phase change, temperature is constant, meaning the temperature is not changing. It is staying exactly the same. And then the last part is right here. Sorry, I don't know why we can't see it. But on a phase change diagram, a horizontal plateau means temperature is staying the same while heat is still being added. And that is it. We will practice phase change in class.